Hi folks, so what we have here is a question based on the topic of solids in contact, and the question here is just in the image here on the right. What we have is a square base pyramid which has a base of 60 by 60, okay, and the overall height of the pyramid is 80 millimeters here. So we have a pyramid that is in contact with a sphere, and then the sphere B is in contact with a cylinder, and that's what we have to draw here, the elevation and plan of all these objects in contact, and then we have to locate the points of contact as well. So starting off, we're going to start off with the pyramid, okay, pyramid A, which is a square base pyramid, as I said, 60 by 60, and it has a height of 80, but it has been truncated here, the top of it has been cut off at a height of 60 as well. So we're going to start off with that there. So, I'm going to start off with an XY line, just drawing a little XY line there, and what we're going to do is, on the XY line, I'm going to pick a start point. So from there, I'm going to draw in my pyramid, which is the triangle in elevation. So from my start point here, I'm going to measure a distance of 60 millimeters. Okay. To get the middle and the height of the pyramid, I'm going to mark in halfway, so half of 60 is 30 millimeters. Okay. And from the middle, I'm going to do a vertical line up. The overall height of that is 80 millimeters in height, which we can see over here. So I'm going to mark up the 80 millimeters. So I'm just going to mark from the 10 up as far as 18, just because the visualizer's in the way there. That's my 80 millimeters. There's my point at the top, and connect that down to my points at either side. Now, as always in these videos, I usually use a little marker. Just helps to distinguish between. Okay, so I've got my X guy there. I'll put my Y out here. That should be plenty enough space. Okay, now what I want to do is I'm going to make the truncation at the top. So that's measuring up a height of 60. So once again, I'm going to use the 10 as my guide, marking from 10 up 60 millimeters as far as 16, and drawing my line going across. Okay, I'll heavy all that in a minute. I'm now going to go down to the plan to draw on my square base pyramid. So from the extreme edge there, I'm going to do a vertical line down and a vertical line down from the XY line. I usually keep a gap of about 1 centimeter to my plan view. It can be any size, but I'm going to measure down 1 centimeter and do a horizontal line there. Now, what I want to do is, you can see here that the width is 60 millimeters, so I'm going to put in the width. So I'm marking down 60 millimeters. So from that mark there down to the 60, there's my 60 millimeter mark. I'm going to draw in my horizontal line. And there is our square base pyramid. Now, the other way we could have done it was, because it is a square, it should meet, the diagonals should meet at an angle of 45 degrees. So I'm going to draw in my diagonals because I do need them. And there we go. That is the pyramid before it has been cut in plan. How do I find that now? Okay, so in elevation, I'm going to draw this in here. I'm heavy in this a little bit. So that's my truncation line in elevation. I'll put in the outside face, plus the outside face here, and that's what my pyramid looks like in elevation. Now what I need to do is I need to find that little square that we're going to see in the plan view as well. So how do I find that? Well, where it hits here on the extreme edge, I'm going to bring that line down. That's going to help me find a point here and here. Where those points hit, all I'm going to do is a horizontal line, and then from there I get a little vertical line, and we can see it. Okay, so once again, let's just heavy in the information. Okay, I'm going to heavy in this line, I'm going to heavy in this line, heavy in this line, and same with the little square for the truncated part. Obviously, in the day of a test, if you're doing a question like this, you're not using a marker. This is just for demonstration purposes. Okay, so there we have it. There's the elevation, there's the plan. I'm not going to heavy in this line just yet because we have to get a sphere that is in contact with it. Now we need to look at the information in relation to the sphere. So you can see here we have a sphere B and a sphere B in plan. And if we look at the sphere, it doesn't tell us much information here, but if you look at the height of the sphere and follow it across, they tell us that the overall height of the sphere from the ground up is a height of 60. Therefore, the diameter is 60, which means that the radius is 30. So how do we find a sphere in contact with the pyramid? What we want to do is we want to bisect the angle between the face of the pyramid here and the ground, which is represented by the XY line. So I'm going to bisect that angle in there. So compass here and here. Bisect into the angle there. Now that I've bisected the angle, I'm going to draw my bisector line. And anywhere, if I was to draw a circle along that line, well, anywhere along that line is going to be equidistant away from the XY line and the side face of our pyramid. Now, what we know about our sphere is that it has a radius of 30. So, from the XY line, I'm going to mark up a height of 30 millimeters. So from here, I'm going to mark up a height of 30 millimeters. And I'm going to do a line across like that. And at that point right there in the middle, that is my center point then. That is both 30 millimeters away from the ground and the pyramid. So just going to draw in a line, and I'm going to draw in my sphere, and it should touch both of them. So setting the radius out to the 30. And there we go. And there is our sphere. Now I'm just going to use the compass once again to go over that. We'll heavy in the information there. Taking my time. So there's the sphere in elevation. Now how do I find it in plan? Well, the center point in plan has to be directly down from the center point in elevation, and it will be in line because it's touching at the side of it, exactly out at the side. It'll be in line with the apex of the pyramid. So that there is now my center point. So I'm going to take the same radius now from up here, put it onto the new center, and draw on my sphere in plan. So there is my sphere. Now that I've got the sphere drawn, I'm going to now heavy in this line and this line, and then pop in the hidden detail. Why is that in hidden detail? Because as we look down in the plan, imagine yourself looking down on it, the sphere here is overlapping this edge, so I cannot see this part of it here inside it because the sphere is on top of it. Okay, so there's the sphere done. Now what we have to do is we have to get a cylinder in contact with the sphere B. We've got the sphere, we've got the pyramid in both views. Now we need a cylinder here and here. So in regards to the cylinder, we can see down the plan it tells us that it has a diameter of 48, which means that the radius will be 24, and then in elevation the height of the cylinder is the same height as the sphere. Okay, so how am I going to draw that? I'm actually going to start it in the plan and bring it up to the elevation. So in the plan, all I'm going to do is I'm going to extend the line out here, okay, and somewhere along that line there has to be the center for the cylinder. So what I'm going to do is, if the diameter is 48, well, from this point right here, let's say the 3 o'clock position on the sphere, I'm going to measure out half 48, which is the radius 24. So from here, mark out 24, and that is my center point, right there. Okay, just going to do a line up and down, like that. And now what I'm going to do is, I'm going to draw in my cylinder. Because in the plan, as it's drawn, we see a circle as we look down top of it. And there we go. There is my cylinder in the plan. Now what I want to do is I want to bring that up to the elevation. So from here, I'm going to bring the outside point up, let's say the 3 o'clock position once again. And likewise right here, that will come up as well. And then what I'm actually going to do, from the top of the truncation there, bring this across, and there we go. Okay, and we can see the rectangle in elevation. So there's that. That. So there is our cylinder in elevation, and once again, just to heavy it in the plan to make it stand out on your screen. So taking our time, neat and tidy with our lines. Okay, and there we have it, guys. That there is the problem completed. The only thing that you would be asked to do at this point in the question though is to locate all points of contact. Now, in the elevation it's quite obvious where we can see them. I can see that the sphere is touching the pyramid right here at this point. okay, and I can see that the sphere is touching the cylinder right here at this point. Once I find them in elevation, I have to find them in plan. Now, you can't just come along and just put a little dot there, you have to prove it. So how do I prove it? What I want to do is, I have to go perpendicular to the extreme face, okay, or the face of the pyramid, okay. So what I like to do here is I take my 45-degree set square, I'll just zoom out a little bit. I take my 45-degree set square, I put the number side on the face of the pyramid, I take my other set square and I put it underneath it, and I want to slide the set square along until this edge here, this side of the set square, comes in line with the center point. So watch, I'll slide it along until it gets to the center point, and from there then I'm going to do a line like this. Okay, now that line there is perpendicular, the line that I've just drawn is perpendicular to the face of the pyramid. It is perpendicular to this line. But most importantly, it identifies to me the exact point of contact, and I would write POC there. Okay, so I found that point of contact in elevation. That's the first one I've done. Now, the next point of contact I want to find is between the sphere and the cylinder. How do I find that? Well, we can see where it is. All it means is the exact same principle. I need to go perpendicular to this, I suppose, generator of the cylinder. Okay, and I'm going to do that from the center point, which is just a horizontal line. So I bring the horizontal line over, and there's my point of contact. Now, how do I find them in plan? In plan, well, this one is here. The line will come down, it has to be right there. So there's my point of contact. POC, put a little dot on it there. And now the other one that I have to find is this one here in plan. This is the one, when I bring it down, the point of contact, it's going to come down. And that's always going to be where the center of the sphere connects to the apex, okay, of the pyramid. And right there, that's where it went down. So that is my point of contact, POC. So there you have it, guys. That there is a problem in solids in contact, where we had a pyramid in contact with a sphere, which was then in contact with a cylinder. And as always, you would have to show the points of contact and any hidden detail relevant to the question. So there you have it, guys. I hope you found that question helpful. That's it done.